So when we're calculating the average value or the expected value or the mean, okay, so we can write that all down. The average value, the expected value, the mean, the mu x, but it is a binomial, all you have to do is take n times p. N, number of trials, p, probability of success. You don't have to do a bunch of things. You don't have to do each number of successes and what the probability is and all those multiplied together and added up. But remember, this is a great shortcut, but it's only a binomial shortcut. Otherwise, we've got to do exactly what we did back here and do the whole chain of multiplications. Or put it in the calculator and let the table do the chain of multiplications. So if I want to say, hey, all 25 of the people in Mr. Curry's class are going to shoot, how many successes do I expect? My average number of successes, and that's what this represents in a binomial, is equal to the number of trials times the probability of success in one trial. The n times the p. And if you think about that, that makes a lot of sense. 25 trials, about 70%, each one has about a 70% chance of making it, so I would expect about 17 and a half successes. And again, it's totally possible something that's discrete can get an expected value that's not discrete. So even though the number of free throws that the total number of free throws that we count can't be a decimal, the expected value can be a decimal. Okay. Here's another example of an expected value. If you get one student that's going to shoot 50 times, how many throws will we expect her to make? Well, she's going to do this 50 times. Every time, theoretically, her probability of making it is 0.7. So we would say we would expect her to make 35. Now, we know human nature isn't that predictable, even though her shooting average is about 70%. Making a bunch in a row can give you more confidence. Missing a bunch in a row can give you more confidence, bless you. So theoretically, each shot is independent in a perfect world, in a non-human world. But in a human world, yeah, we know. Making a bunch of them, missing a bunch of them, nerves, every time you go to shoot, and especially doing 2 or 3 in a row, anybody who is a basketball player will tell you, I'm sure, there's some kind of effect. Right? There's an emotional effect that might shift that probability. Remember, we're always talking about in theory. Okay? If on average she makes 70% of her free throws, when she shoots 50 of them in a row, we're going to expect her to make about 35. Now, standard deviation. A little bit more. We're going to actually need to use the formula this time. There's a formula that we're going to use. It's an easy formula, though, for binomials because it just has a few pieces to it. You'll notice, again, we have n, and we have p, and we have 1 minus p. So remember, n is our number of trials, p is the probability of success. So 1 minus p is the probability of failure. And remember, I told you some textbooks use a Q for that. We're going to multiply n and p and 1 minus p, and then take the square root of the whole thing. You got to remember to take the root. That's usually the part you forget. So, this same chick who's shooting 50 shots, and we're going to expect her to make 35 of them. Well, what kind of variation are we going to expect? What would be sort of the most likely range that her numbers of shots would fall through? Our n is still 50. Our p is 0.7. Our 1 minus p is 0.3. So I'm going to take the square root, and under the square root, I'm going to multiply 50 times 0.7 times 0.3. It's a lot scarier looking formula when you just look at it with symbols. When you actually look at it with numbers, you're like, oh, okay, duh. You're going to multiply three things together and then take the root of it. So 50 times 0.7 times 0.3, square root of that. So I think that's actually 10.5 underneath. So it's the square root of 10.5, which is about 3.24. So we would say, we're going to expect her to make about, what do we say, 35? Yeah, 35 plus or minus 3. Yeah. People talk like that all the time, like, I'm going to expect this plus or minus this. That plus or minus concept is the idea of standard deviation. People are rarely calculating that. Oftentimes they're just kind of gut feeling that, but yeah, that's kind of the idea. Yeah.
What's the Q for again?
So the Q is just some textbooks use that instead of 1 minus p. So if you ever see a calculus, if you're taking stats in college and they're like n times p times q, and you're like, woo, who's q? Q is just 1 minus p. I've seen it written both ways, and I don't know why people do it different ways. I don't know why some books decide to use a Q. Maybe because Q is cool. All right, so 3 new things today. The idea that you can do the cumulative ones with a shortcut. Nice. The expected value and the standard deviation for a binomial. Easy formulas. Okay. I don't know a way, other than knowing the whole distribution for binomial, I don't know that there's another way to get it to the calculator to tell us those directly. There might be a built-in function for that, but at this point, I don't know it, and Mr. Hawkins is pretty good. Once he told me what CDF, I was like, what else aren't you telling me? He's like, well, did you know this? I'm like, yeah, okay, I knew that. So hopefully there's nothing else that I don't know. But yeah, last time when I learned this, I was doing a table. Okay, so hopefully the idea is you can do some questions. You can go through this draw 3, get it 3, the free lunch question, and figure out some stuff. And then you can do the phone call question and figure out some stuff. You've got some cumulative probability questions, a couple expected values, a couple standard deviations.